Is it your turn?
It could be one of your kids.
Nope. Okay. Lesson 4.2.3. Solving right triangles. If I'm not mistaken, when we solve right triangles, it's going to be a little bit more geometry review. Okay. While I was getting ready, I asked you guys to try and fill in the chart. I did go ahead and draw in the triangles over here, right? Don't be afraid to draw those on your paper. If you don't have access to your chart, don't be afraid to draw those into your paper. Remember the 45, 45, 90? My legs are equal, so 1 and 1. The hypotenuse is square root of 2 times the leg. 30, 60, 90? My short leg is 1. The hypotenuse is twice that, and the long leg is square root of 3 times that. Okay, radians. Let's fill in the radian column. 30 degrees is what in radians? You guys got to tell me.
Pi over 6.
Pi over 6. There we go. And if you didn't remember, you get that by multiplying by pi over 180, right? So work on memorizing it, but if it's not memorized, just multiply it. Okay, what about 45? Pi over 4. And 60 degrees? Pi over 3. Memorize them or know how to find them? I don't care which. Okay. Sine of 30 degrees. 1/2. And I never wrote it yesterday, but you can go back and use SOHCAHTOA, right? If that's helpful to have written on your paper. Okay, sine of 30 is opposite over hypotenuse. Let's go ahead and do the 30-degree row. I think that's easiest. What about the cosine of 30? Okay, adjacent over hypotenuse, square root of 3 over 2. And tangent of 30?
Square root of 3 over 2.
Okay, it's opposite over adjacent. The final version is square root of 3 over 3. If you start with 1 over square root of 3, that's equivalent, isn't it? I guess I usually put the word or in there, don't I? So starts as 1 over square root of 3. When you rationalize it, it's square root of 3 over 3. Be able to recognize both. I will accept either or when it comes quiz time eventually. Okay, 45 degrees. We're going to switch triangles, right? You're going off of the 45-degree angle. Sine is opposite over hypotenuse. So it starts off as 1 over square root of 2, 1 over square root of 2. But the one that you're going to be more familiar with is square root of 2 over 2. I agree. What do we know about cosine of 45?
Square root of 2 over square root of 2.
Okay, square root of 2 over 2. It's the same, isn't it? The sine and cosine of 45 are the same. So I can say 1 over square root of 2, 1 over square root of 2, or square root of 2 over 2. Tangent of 45. 1. Opposite over adjacent. 1. Okay. Sine of 60. So now we're back to our other triangle. We're using our 60-degree angle. Opposite over hypotenuse. Square root of 3 over 2. It's also equivalent to the cosine of 30. What's the cosine of 60 equivalent to? Sine of 30, yes? Or cosine is adjacent over hypotenuse, so from 60, 1 over 2. And what about tangent of 60? It is square root of 3. It's the reciprocal of tangent of 30, or from 60, opposite over adjacent, so square root of 3 over 1. You know how to fill that in? Because if so, you know how to ace your quiz coming up, which I can't tell you any clue when it is because I don't know when, I don't know what the rest of this week looks like. So usually after I teach this chart, we'll usually continue on, we'll do some random practice, and then I will eventually have you do a quick, it's like a 10-minute quiz at most. Okay? And so eventually we'll do a quiz. I'll give you warning though. It won't be a random walk-in surprise thing. Okay? Okay. Moving on. Today, we're going to be finding missing sides and angles. Okay, so based on these following right triangles. So when we're talking trig and we're talking about sine, cosine, and tangent, we're talking right triangles here. Okay, so if they're not right triangles, we can't use these trig functions. We're being asked to find the missing sides and angles. Now, as we look at A, we need to find side length A, side length B, and we have one missing angle up here, don't we? That we need to find the length of. Thoughts on what we could find here? The missing angle is going to be the easiest, and that goes back to, I don't know, I almost feel like that's elementary math technically, but I don't know. It goes back to a detail that you learned years ago. It's just a matter of whether you remember it. What do we know? Jacob?
The triangles, all the angles add up to be 180.
Okay, all three angles in a triangle always add up to be 180, yes? So in this case, how am I going to find this angle right here? I don't know, everyone's going to do this their own little way, I'm sure, right? I personally would probably say add 90 and 37 and subtract from 180. I have written in my notes 180 minus 90 minus 37. You do you, right? So if we say 180 minus 90 and minus 37, or you could say 180 minus 127. You can think of it either way. What do we end up with there? 53 degrees. There's technically one other way you could find that 53 degrees.
90 minus 37.
Yeah, 90 minus 37. Because in a right triangle, if one angle is 90, the other two have to add up to be 90, don't they? So you could also say 90 minus 37. Use whatever math you want there. Okay, we got the easy part done. All three angles in a triangle add up to be 180. Find the missing angle. Thoughts on how to find side A or B? We're going to have to talk trig functions here. We're going to have to think about our trig function relations. Of SOHCAHTOA. Have we seen anything we can maybe try? Give me a little more hint from me. My question, if we work to find A first, okay? My question to you is going to be, what connects the 37-degree angle, the side of A, and the one side we do know of 8?
The sine.
Sine? Because our relationship for sine is opposite over hypotenuse, yes? So we can set up basically an equation, a very basic equation that we can use to find this. So the idea that we know 37 degrees, so I'm going to say the sine of 37 degrees It's equal to opposite over hypotenuse. So it's equal to a over 8. Is that an equation you can solve? How do you solve for a? How do you get a by itself there? If it's a divided by 8, we're going to multiply by 8. So I'm going to rewrite this, because if I multiply both sides by 8, I'm going to rewrite this that a is equal to the sine of 37 degrees. Does that make sense to you guys? Since it was a divided by 8, to get a by itself, I'm going to multiply the 8 over to the other side. If I multiply the 8 over to the other side, it's 8 times sine of 37 degrees. Now, I would hesitate and warn you to be careful about putting sine of 37 degrees times 8, because you don't want it to become 37 times 8 and then the sine of that, which is why I always put my other number out front. And do you know the sine of 37 degrees off the top of your head? Is that one that's in our chart? No, we've got 30, 45, and 60 in our chart. So what are we doing here? We are using our calculator. And you're going to do a basic 8. You can hit times or not. Sine of 37 degrees. Does your answer match my answer? Did your answer match my answer? I guess I didn't tell you what my answer is. 4.814520185. It should match. If it doesn't match, what mode do you need to be in? Okay, this is 37 degrees, yes. So you do have to be in degree mode. I have 2 decimal places written down today. So I have 4.81. So that would be my main hint. If you didn't get the matching answer, make sure you're in degrees, because these are degree numbers, not radian numbers. I will say, if you entered sine of 37 first, you can do that as long as you close your parentheses and then say times 8. The problem you run into is if you don't close your parentheses, there it's doing the sine of whatever 37 times 8 is. So that's the no-go. Did you get your calculator to cooperate with you? One way or the other? Okay. So, we found the missing angle. We found side A. We're not done. We need to find side B. Got any thoughts on B? And I will tell you, there's not just one way to find B. There are multiple correct ways to find B. There were technically multiple correct ways to find A, but what would you guys do for B?
Cosine.
Cosine? Could we still use this 37-degree angle here? We can. And so we can look at the fact that the cosine of 37 degrees, keep in mind cosine is adjacent over hypotenuse. So cosine of 37 degrees is b over 8. If we do this, it's b divided by 8. So what do I have to do? I'm going to have to times by 8. So it's going to be 8 times cosine of 37 degrees. And of course, it's use the calculator at that point. You should be in the right setting at this point. 6.38908408, or approximately 6.39. Okay. Could you have used your 53-degree angle? You could. Okay? If you're confident in your math, in other words, you didn't mess up the basic subtraction, there's nothing wrong with using the 53-degree angle to find either A or B. I tend to go with the given angle just because I am confident in my 37 degrees. I know I didn't mess anything up there. There's always a slim chance I messed up the subtraction on the 53. So you could do this other ways. This is not the only way to get the correct answers. So if you go back and try it and say, okay, well, for B, I did the sine of 53 degrees is B over 8. You get the same answer. Okay, ready for part B? Take me through it. We're given 57 degrees. We're given a side of 13. We need to find x and y in our missing angle. What are your thoughts? Nothing.
Sine of 57.
Okay. Sine of 57. And if we do sine of 57 degrees, that's going to be what? 13 over x. And again, keep in mind, you might do something different. There's multiple different ways to do this. So, sine of 57 degrees is 13 over x. Now, at some point, we're going to hit one where the variable's in the denominator, so we hit that. You have to think carefully here. If this is 13 divided by x, what am I going to have to do here? If it's 13 divided by x, we're going to have to multiply by x, and we're going to move x to the other side. So this one's going to look a little different, but we'll end up doing something similar. So it's 13 divided by x. I'm going to multiply by x. So then, when I multiply both sides by x, x times sine of 57 degrees equals 13, because my x cancels on that side, correct? How do I solve for x from here? If it's x times the sine of 37 degrees, excuse me, sine of 57 degrees, we're going to have to divide. So when we divide both sides by sine of 57 degrees, I end up with x equals whatever 13 divided by sine of 57 degrees is. Sine of 57 is the only thing in the denominator, so it shouldn't be a big deal to enter it on the calculator. But I would double check, make sure your answer, you can get the right answer. Did you guys get an answer? Doesn't match mine. 15.50072281. So approximately 15.5. Okay. I found one thing, one missing piece. I need two more. What next? Okay. He says the tangent of 57. That works for me. So if we do the tangent of 57, tangent of 57 is going to be opposite over adjacent. So 13 over y. Did you guys follow okay how to manipulate the equation? If it's 13 divided by y, I'm going to multiply by y. So y times the tangent of 57 degrees is going to equal 13. If it's y times the tangent, I'm going to divide by tangent. So 13 divided by tangent of 57 degrees. What'd you guys get? Okay. I remember the 8.44 part. So 8.44. Okay. If you're someone, and as we just did this problem, you're like, oh, I really don't like when the variable comes up in the denominator. I don't like having to do the extra step and to divide. You can manipulate, you can pick different options here. Okay. For instance, in order to find y, well, we haven't found this angle yet, but you could have used this angle here. Tangent of our missing angle equals y over 13. Then you would have y on top if you want. Okay. Now, getting the hypotenuse on top, x, not really an easy thing unless we're going to use our reciprocal functions. Nothing says you can't use the reciprocal functions, but sine, cosine, and tangent are so much easier to just push the button on the calculator, aren't they? We don't have to think about raising to the power of -1 or anything. So, what's my missing angle?
33.
33 degrees. Okay, so 180 minus 90 minus 57 is 33 degrees, or however you did this. 90 minus 57, 180 minus 147. You got something, right? Okay. You're catching on, yes? Let's been short on time last time I did this. Let's go ahead real quick. So we've got C, and then we've got example 2, and I don't have a backside, right? Yeah, we got this. Okay. Where do you want to start?
Missing.
What?
Missing degree.
Missing degree. He wants the easy one. Why not? What is that missing degree? (180 minus 90 minus 21 is how many degrees? 69 degrees. If you're confident in that math as you proceed, you can use the 21 or you can use the 69 degrees. Doesn't matter. Okay, what are you guys finding, M or N?
Let's make it equal. Let's find N.
Ooh, you want to find N first? Okay, how are you finding N?
Let's do a sine of 69.
Oh, he's going to mix it up on us. He's using this 69 degrees. He's confident that we have subtracted correctly. Okay. Sine of 69 degrees is opposite over adjacent. 14.2 over N. And if you don't like this method, pick a different route, right? Meet me in the end. This is a good practice run. So for this, If it's 14.2 divided by n, I'm going to multiply by n. So n times the sine of 69 degrees equals 14.2. If it's n times 69 degrees, I'm going to divide. 14.2 divided by sine of 69 degrees is what I ended up with. Mathematically, what does n come out to be? What did you guys get?
15.2.
I have 15.21 written down, but yep. Okay. Did you guys all do it the same way? Or did you try something different? Okay. I need an M. How are you getting M? Okay. He's picking tangent of 21 degrees. So tangent of 21, opposite over adjacent, M over 14.2. Let me throw in a comment before I forget, okay? You guys didn't attempt it, so it's not an issue, but I don't care if we're using the angle we found, because that's a nice, neat whole number, yes? However, should I try and use the rounded version of n to find my value of m? No. Go with the sides they give you. Don't try and use a rounded side. You could use a rounded side to an extent, but it is going to throw you off a little bit, possibly. Okay? So m divided by 14.2 means I'm going to multiply by 14.2. So 14.2 times the tangent of 21 degrees. And I have 5.45 written down. Okay. This is basic trig stuff, right? I'm guessing you solved triangles like this back in geometry. Not saying you remember it, but this shouldn't be totally new. Okay, hopefully it's a better understanding this time. But this is something we'll use on and off as we go through the rest of the chapter. This also leads very well into word problems. Okay, so final example. From a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia, the angle of elevation to the top of the building is 65 degrees. Find the height h of the building. So very typical trig word problem. Now, I'm not saying you need a picture, but that's always my go-to here, is let's draw a picture. From a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta. So, here is my very fancy building. Okay? That's what I draw for buildings. You know what? You can be even less fancy than me and just draw a line. Okay? But I'll get it here. This is my plaza. From a point 340 feet away from the base. So, okay, from a point 340 feet away from the base. The angle of elevation to the top of the building is 65 degrees. Do you understand angle of elevation? That's as you're standing at ground level looking up, the angle between the ground and your line of sight. And so that's saying that that angle right there is 65 degrees. That's my angle of elevation. What are we being asked to find? The height of the building. Oh, I just looked at my notes. I even got fancy last year. There's a person. point is, what did I just draw? I just drew a right triangle. The person aside, the plaza aside, I drew a right triangle where I know the base is 340. I know there's an angle of 65 degrees. I'm going to try and define the height. There's a right angle because the ground and the plaza make a right angle, hopefully. So, what are you doing to solve this? Yep. And what is the tangent of 65 degrees equal to? Okay, h over 340, yes. Look for these right triangles as you run into word problems. If it's h divided by 340, I'm going to times by 340. So it's 340 times the tangent of 65 degrees. 340 times tangent of 65 degrees. I have 2 decimal places in my answer. Get 700 something. I have 729 and 1300ths feet. Okay, very common usage of trig there. Given an angle and a side, we can definitely work with that. Okay, your homework is page 335, 49 to 58, 61 to 65. Should go right along with what we've been doing today in homework or in the lesson. Do pay attention. If it says find all missing angles and sides, you're probably finding 3 items, aren't you? Because you're probably finding 1 angle and 2 sides. And so do watch that. In terms of e-learning, I'll be honest, I don't really know what I'm going to do. Okay? So there's a chance we're here tomorrow. There's a chance we're not here tomorrow. Okay? I don't know. Definitely have your notes home with you in case I decide to proceed in any notes along the way. I don't know that I will, but there's that possibility. Have your book accessible, right? I doubt I'll do, I don't know if I'll do any notes, but I'm going to go ahead and give you guys a paper copy of a unit circle that you can just stick in your folder, your notes, that I usually hand out in lesson 4.3. So I'm going to go ahead and give that to you. Just hold on to it, okay? Oops, sorry. Just hold on to it, and we'll get to it eventually. There is a chance you may see some IXL pop up in e-learning, depending on how long we end up with, 1 day versus 3 days versus 5 days, Who knows what I'll do, but you could see some notes, you could see some homework, you could see some IXL. I could get creative and come up with something different. But do make sure you take your stuff home tonight. We could be here tomorrow, we might not.